Now let us find out what will be the current values, the currents which are defined to be I1, I2 and I3. We have to find these three currents also. So I'll once again consider the original circuit. Now in this circuit, let us write down the expressions for I1, I2 and I3 one by one and see what are going to be their values. So let's first look at I1. Whenever we find the value of any current, its direction plays very important role, because if you do not consider the given direction, then you may get the correct value, but the sign of the current may not be correct. So this time I have to find out I1, which is flowing towards left. Now the current which flows towards left through this 2.2 ohm resistance will generate the voltage across 0.2 ohm with the polarity minus on the left and plus on the right, because whenever the current flows, there is always fall in voltage that appears across the resistance. So we have to consider this direction of current, and the voltage polarities that are generated will be minus and plus. So now what will be the equation for the current I1? We are going to apply simple Ohm's law, the potential difference upon the resistance. There's only single resistance, so we will consider it to be 0.2 ohms in this case. The voltage, the potential difference, will always be the one which is there on the positive polarity side minus the one which is there on the negative polarity side. So in this case, I1 will be nothing but VA on positive polarity side, and negative polarity side, there's a positive voltage of 120 volts. So I'll just write VA and 120, and then I'll put a minus sign because we need potential difference, and we divide it by 0.2. We already know the value of VA from the previous discussion, so let me use that value. VA is 112. That gives me 112 minus 120 upon 0.2. So when you solve this, this will be minus 8 upon 0.2, and it will come out to be minus 40 amperes. So it is minus 40 amperes with the direction which they have given towards left. I can also write the value of I1 as plus 40 amperes, mentioning its direction towards right. But this will not be the correct answer as per the given direction, because they have mentioned directions towards left. So we have to stick to the direction, and as per that, the correct answer that we must mention is minus 40 amperes. But if you just want the current in this branch, then it is also plus 40 amperes flowing towards right. So that's the first current I1. Let's write down what is the expression for I2. I2 is flowing towards right. So the polarity of the voltage will be plus on the right, minus on the left. On positive polarity side, we have voltage VA. Negative polarity side, we have VB. So it's VA minus VB divided by resistance is 0.3. VA is 112 and VB comes to be 109. And if you divide this, you get 0.3. So I2, when you solve, will come out to be 10 amperes. And finally, and that 10 amperes is with the given direction, which is towards right. And finally, let us write down what is I3. I3 is flowing towards left, so the current flowing towards left will have the polarities of voltage across resistance as minus and plus. On positive polarity side, you have voltage 110, and on negative polarity side, you have node voltage VB. So it's 110 minus VB divided by the resistance, which is 0.1 ohm. So this is going to be equal to 110 minus VB, which is 109 divided by 0.1, and this will come out to be 10 amperes again. And I'll just mention the direction, which is towards left. Mentioning this direction is optional. You may not mention them because we have already shown the directions in the circuit, and we have written the values as per the directions. This is just for our understanding. So that's a complete solution using nodal analysis. This was a question where two resistor values were unknown, but instead of that, they had given us the branch current. So any form of information is sufficient in solving for unknowns that we have in the circuit.